Let's look at this example on curve sketching. It says find and classify for the stationary points, or for the function, or let me say that again, find and classify the stationary points for the function y equal x cubed plus 4x squared minus 3x plus 6. Sketch the function and label the stationary points of inflection and the y-axis. Alright, let's look at this. We're going to find out where the stationary points are. And we need the y-intercept as well. Alright, let's look at the y. Alright, let's go one step at a time. Stationary points. This is a cubic function. I expect that, well, there will be two stationary points. Alright? Now, to find the stationary points, we need to find the gradient function and find the points where the gradient equals 0. The cubic functions can be shaped like this or like this. Alright? These points where the gradient is 0, if you draw a tangent, you'll find a horizontal line there, the gradient will be 0. Alright? Now, what we need to do is find the gradient function. My curve here was a bit too sharp. Let me smooth out what the curve might look like here. Alright, it's more like it. So, here now, find and classify the stationary points. We need the gradient function and then equate it to 0, because the gradient function is going to tell us what the gradient is if at a certain point if we substitute x in it, and then what we do is equate it to 0, because at the stationary points the gradient is equal to 0. So let's look at that. Let's differentiate dy by dx equals, so we're finding the stationary points now, the SPs. Dy by dx is 3x squared plus 2 by 4, 8x minus 3. That's the gradient function. At the stationary point, the gradient is equal to 0. Now this is a quadratic equation. We can let's solve this using the quadratic formula. X equals negative b, that's negative 8 plus or minus the square root of b squared, which is 8864, minus 4ac, 4 by 3, 12, 12 3 is 36, was a negative 36, all over 2a, which means 2 by 3. Now, this is negative 8 plus or minus 64 and 36. 6 and 4 is 10, bring down the 0, carry 1, 6 and 3, 9 and 1, 10. So you will have the square root of 100, which means 10. Square root of 100 is 10. Over 2, 3 is 6. Alright? So now, x equals 8 plus 10 over, negative 8 plus 10 over 6. Negative 8 plus 10 is a positive 2. 2 over 6 is 1/3, which is 0.333. Let's call it that. And also, x equals negative 8 minus 10 is negative 18 over 6. Negative 3. Alright. So, these stationary points are located at x equal 0.333 and negative 3. So let me just make a note here. SP's. X equal 0.333 and x equal -3. Alright, so we have the location of x where the stationary point are. Now, since we have the x values, we can find the classification, whether it's a maximum or minimum. Now, the first derivative tells us what the gradient is at a certain point, right? In other words, how the curve changes. The second derivative will tell us how the gradient of the curve will change, whether it's increasing or decreasing. So, let's find the second derivative, d squared y by dx squared. What is that? Going to be 326x plus 8. Now, what happens at 0.333? At 0.333, d squared y by dx squared equals 6 times 0.333 plus 8. You don't really need the actual value. You know that this is positive. So the gradient, the stationary point at this point will be a minimum. Alright? At x equal 0.333, gradient will be minimum. It's minimum at x equals 0.333. It should be maximum at the other point. Now 6 times -3. 6 times -3 plus 8 will be -18 plus 8. At the other point it's -18 plus 8. Alright? So remember, we can see, even though we can calculate it quickly, we can see that the value here will be negative. So there will be a maximum point, right? It's -10. There will be a maximum point at x equal -3. Max at x equals -3. So it's a maximum at x equal -3. So if we should just sketch our x and y axis, alright. So far we know that there is an x equal 0.33 and a -3. So one of them will be at 0.33. If we make this 1, 2, 3 and so on, -1, -2, -3, -4 and so on, alright? One stationary point will be somewhere lined up with -3, and the other one will be lined up with 0.33 or 1/3, somewhere there. But anyway, what we know also is that the one at 0.3 is a min and the other one is a max. 0.3, this will be a minimum point. We don't know exactly where it is yet. So let's just do this and this. So far, to get exactly where it is, we need to substitute the y value. We need to get the y values. Alright? In other words, we need the coordinates of the stationary points. we know that it's located at x. One of them is located at 0.333. What's the y of that? So let's erase part of this work and make some space so that we can get our y's. So far we know that the stationary points are at 0.333, comma, something else. We want the full coordinates. The other one is at -3 and somewhere else. So in this case, when x is 0.333, what is y? Let's use our calculator, because what we know already is the x value where the stationary point is located. We want to find out where on the y-axis it is. 0.333 times 0.333 times 0.333, that 0.333 cubed plus 4 times 0.333 squared is that, minus 3 times 0.333, okay, plus 6 equals 5.48. 5.48. Alright. So we have an idea where exactly where one of them is. What about the other one? When you have x equals -3, -3 by -3 by -3 is going to be -27, alright? Plus 4 times -3 squared is a +9. Minus 3 by -3 is going to be plus 3 by 3, which is a +9. Plus 6 equals, we have 24. So 24 is what we have here. So what we have here are 0.3, 5.48, 0.3, 5.48. Let's call this 5 up here. 1, 2, 3, 4. Call this 5. Let me say that this is the 5. So 5, 6. 5.48 will be somewhere here. Just kind of line up with it. And then the other point is at -324. So -324. Oh, it will be way up. Alright? 24. So I'll have to recalibrate or redraw the graph. Let me put the 5 point something down here and then -324 up here. Now these are where the stationary points are located, and what we have is that the one at -0.33 is a minimum and this is a maximum. So we have 0.33 minimum. So this is a minimum and this is a maximum. Alright, so we have that so far. Now, what else do they ask for here? They say point of inflection. Where exactly is the point of inflection? Where the point of inflection will be somewhere along here, but let's calculate it. When you have 6x plus 8 as a second derivative, 6x plus 8 equals 0 will show you where the point of inflection is. 6x plus 8 equals 0. 6x equal negative 8, x will be negative 8 over 6, which will be what? Negative 2 into 8, 4, 26, 3, which will be negative 1 and, well, negative 1 and 1/3, negative 1.333. Alright, negative 1.333, somewhere around here. Point of inflection. Let's look further at this. The y-intercept. The y-intercept is when x equals 0. When x equals 0, you see that this will be y equals 0 plus 0 plus 0 plus 6. It will be at 6. So the y-intercept will be at 6. So you have 6 here. Alright. The point of inflection, negative point, let's call it negative 0.35.4. Negative 0.35.4. Alright. Oh. Negative, let me look back at it. Negative 324. Right. So it will be negative 324. So this point is up to 24, negative 3, and then the other one is at negative, it is at 0.35.48. So this is 0.3, 5.48. The height of this is 5.48. Alright. The y-axis is at 6. The point of inflection. Where was the point of inflection again? At x equal negative 1.3. Alright. Point of inflection located somewhere here, negative 1.3. Alright, but anyway, let's plot it on a graph and see what's happening. X cubed plus 4x squared. Let's open our graph plotter. X cubed plus 4x squared minus 3x plus 6. X cubed plus 4x squared minus 3x plus 6. X to the power of 3 plus 4x to the power of 2 minus what again? Minus 3x plus 6 minus 3x plus 6. Alright, what will our graph look like? Okay, let's see if we really are correct. We have seen that, let's open the graph again. The maximum point is at negative 3.24. Alright, this is indeed at 24. Let's see what happened here. Which line? This line. Negative 3.24. Good. And then the other point is a minimum at 0.3, 5.48. Let's see. It's 5.58. Which 5.58? It should look like 5.48. And this is 0.3. Just about there, right? The y-intercept is at 6. So it cuts the y-axis at 6. We can see it here. Good. By the way, you say the y-intercept is at 6. Let's look at something else too. The first derivative, we want wanted the y-intercept. We found the y-intercept. When x is 0, 0, 0, 0. Right. Y is at 6. Good, good. Nice. All right. So, that's a curve that we have there. So, anyway, that will be it for this video. All right. I'll see you in the next video.